I'm doing like an automated slideshow. No, I'm just saying for the
Alvaro, sorry to interrupt you. All yours.
Okay, so we're going to start the session this morning here. We're going to start the agenda with some words from Alvaro regarding update on our plans for routing in the data center, and then we'll move on to the other presentations shown here.
Thanks, Chris. Hi, good morning. Okay, Alvaro Rutena, I'm the routing AD. So we've been discussing here in this working group for the last maybe a couple of IETF cycles, some proposals and other things around routing in the data center. And we had some presentations on Monday, right? Monday was the other day, right? And so there's been a little bit of confusion of what we're going to do, where we're going to go forward, how we're going to do this. Are we going to do this? It's one of the big questions, of course. So what I think the plan is going to be going forward, this is, we'll send an email probably next week to the working group so that everyone actually knows. I think we all realize that there are specific, maybe special, different, however you want to call them, requirements or circumstances inside of the data center. Some of them have to do with the regular topology, some of them have to do with the way that we want the potential routing protocols, routing solutions to behave inside the data center, ease of deployment, other things along those lines. So that could lead us, or has led us already, to define solutions for the data center that are not just the regular routing protocols that we have today. So this also means, at least in my mind, that we may have more than one solution, because not all the topologies are the same, not all the data centers are the same size, not everyone evolves at the same speed, not et cetera, right? So what we're going to do is the following. The plan is, or the plan was, if you remember from last time, for someone to go off and come up with requirements, and then we would discuss it. Well, that didn't happen.
It's happening, but very slow.
Okay, so Jeff says it's happening, but very slow, which to me it means it didn't happen for this IETF. So what we want to make happen for next IETF is what I want to do, and I'm open to suggestions and questions and flames and everything else you want to do, is hold a non-working group forming BOF in Singapore to do two things. One, discuss some of these special circumstances and characteristics that we think we need. And two, go over the solutions or some of the potential solutions. The idea is not, this is really important, not to have a beauty contest or a winner necessarily, because I just said that I believe, and maybe you guys do too, that we may have more than one potential solution. So the idea is not to say, oh yes, solution one is better than two, because it may be better in some circumstances, but not in others. If we do that, and if we identify interesting solutions that, for which we can also identify interest in the IETF to work on them, then we can figure out what the next steps are. meaning we're going to work on something specific. Do we charter a working group? Do we charter two? Do we bulk everything into one? Whatever the conclusions at that point, then we can go forward and figure something out. So that doesn't necessarily mean, and that's why I think that there should be non-working group forming, that we are going to end up with a working group. It doesn't mean we're going to end up with anything, right? Because we not only need to identify whether the work is interesting, we need to identify whether the work is something that we should do in the IETF, and of course we need to identify, like with any other new work, whether there is interest. Because as much as any solution that any one of you may push, if you are the only one to want to work on that, then there's not a lot of point in creating anything inside the area or the IETF at all. So that's it. Almost it. You guys start. Jeff is going to help coordinate some of the proponents around so that we can have some discussion at the beginning of that BOF. If you are interested in presenting something in the next few weeks, hopefully I'll identify chairs and we'll go forward from there. Obviously, all of this is subject to discussion and other process parts in the IAG and with the IAB as well.
Rick Taylor. Just sort of kind of clarifying question. From my understanding, the purpose of the IETF is really around interoperability, particularly with routing protocols. Does this protocol work on my box and yours? Within a data center, surely you own everything in that data center. It's owned by whoever is running it. Is there interoperability there? I mean, it's not my field of expertise, so it's my question is, if there's interoperability, sure, this is valuable work. If it's silos of technology owned by single users, corporations, is this valuable IETF work at that point? Or are we just showing off our funky protocols?
So I'm going to say yes. There is interoperability is important. You're right. It's my data center. It's my stuff. There are my boxes. Probably I bought all the boxes from the same person. However, that same vendor obviously probably sold the same solution to different people. So from that point of view is where I think that's one of the valuable point of views of having interoperable protocols. The same way that you have your internal network and you can run, buy everything from one vendor and run OSPF or OLSR or anything you want, right? Okay.
Stuart Bryant. So I accept the need for doing specialist routing protocols in the data center, absolutely. But I notice it's part of a trend for domain-specific routing protocols, and I wonder whether we want to go up a level and create a toolkit so that you can build domain-specific routing protocols, and then the data center one might be a profile.
Sure, that may be something that we do. One of the things that I want to do is create a mailing list, of course, so that we can specifically discuss that and take that off the plate a little bit of this working group so that we can have clarity and focus on that. So hopefully I'll get that done in the next couple of weeks and we can start having discussions like that. Because yes, that's another potential option, right, that we can go forward with that. Les
Ginsberg. It's kind of a mundane question, but there are various drafts in protocol working groups at the moment. What, if anything, does the process you're starting have to do with how they progress?
I'm going to say nothing. I just said nothing. So I think that there's a class of solutions that, of course, are around enhancements to current routing protocols. There is already work that has been done and published as RFCs that I personally believe could be used to enhance routing protocols in the data center, for example. So I don't want, this is not my intent, to slow anything else down. As I said at the beginning, one of the important things here is to gauge interest and enthusiasm. And if there is work extending specific protocols, and the extensions happen to be around data center stuff, and there's interest in the working group and the process is followed and all that stuff, I'm fine with that. That's it. That's all I'm going to say. that was nothing.
So a few more comments. So there's some new features coming up, common silicon that would enable us to build non-closed topologies, and we need to start looking into protocols that could address non-classical data center topologies. That's number one. Number two, we see data center getting out of data center, so lives being at the edge, which requires quite different set of features in routing protocol. So long term, we need to address all of this, not just BGP in DC, which works perfectly fine and hundreds of people have deployed. So it's natural evolution of routing, and long term, this is where we would like to take it.
Okay, thank you.
Okay, so next up on the agenda is Stuart Bryant. Excuse me? No,
We don't have to
Karidi is not on the agenda, but
Not yet.
yeah,
Okay,
yes.
just a discussion we had beforehand. Okay. All right, I need this, don't I? You need to provide me with some slides. And is that a pointer?
Gotta go to full screen mode. Now it should work. It was working earlier, but.
Right. Okay, so I wanted to talk to you about some thoughts that a group of us had around enhancing virtual networks. You'll have seen all the pieces before, but what surprised me was the elegance with which they fitted together to build a bigger solution than the pieces. So the problem we set ourselves was how to build a VPN that was enhanced to support both static and dynamic isolation, low latency, low packet drop, seamless integration with both physical and virtual network and service functions. Simply needed to be simple to create and delete and modify the network. And the reason, if you've sort of seen what I've been doing recently, why we wanted to do this was to support 5G. And can I say the N word?
No.
To support the subject of a BOF earlier this week. But the important thing is that we think this is a useful set of facilities to have in their own right, and thus is worthwhile doing regardless of what happens in the mobile phone industry. So one of these. So we wanted to build a layered solution. So the way we approach this was we assume we've got a substrate or underlay that will provide the resources that we need. And what we're going to do is to overlay a number of VPNs on this, such that each VPN can draw specific resources from the underlay to provide the services that it needs to provide. And in particular, it can have dedicated resources if it needs them. We call this a VPN. This an enhanced VPN or VPN plus. It is the importance of the dedication of the resources that allows us to have the performance guarantees that we're looking for. And to do that, we think we need much tighter coupling between the overlay and the underlay than we normally have in networks. So, for example, if you're providing hard isolation, you may have a dedicated tunnel as opposed to a shared tunnel in parts of the network. So we're going to explain this step by step. As I say, you will have met all the steps before, but I was surprised at how easily they went together. So we're looking for fine-grained. First off, we were assuming we were going to use a segment routing construct. And the reason we wanted to use that is because it provides a good way of providing a fine-grained steering of the packets through the network and through compute resources in the network. So segment routing is normally described as providing paths and nodes and links. But of course, as you will have seen from stuff we've explained in MPLS, we can get it to steer through service functions, and I think we can get it to steer through many other utilities in the network. So we can use that to provide the isolation between the VPNs and the guaranteed latency by setting up the resource chains right. And the advantage of this, as is well known, is that there's less core state needed to be maintained to support this. We wanted to build a system that was unified for both IP and MPLS because there's going to be quite a significant sort of control plane, or rather offline compute function behind this. And it'd be kind of nice if we could do it once and not have to re-engineer two completely parallel solutions. And we'll also be, although we haven't advanced very far in this, need to introduce a hybrid control plane containing both SDN and distributed protocols. So classically, VPNs are stateful. At least the MPLS ones are stateful. In order to specify a path through a network, you use something like RSVP, or you use a network management system or an SDN system to lay precise state into the network so that the packet is steered through. As we increase the precision, our view, and specify more and more components of the network, our view was that this state was going to become harder to manage. And so, and this was going to be particularly the case as we had further integration between the underlay and the overlay. So we've seen this all before. Segment routing allows us to construct the paths through the network. So for example, to send a packet ABDE, we simply construct the segment list ABDE and push it on the packet. And normally we sort of think of this, we normally think of this as ways of constructing traffic engineering, but of course we can use it to construct an explicit VPN as well, which is not something that's been vocalized very much here. And the important thing there is that we create the VPN simply by handing SID lists to the entry points of the network. So the only thing that communication needs to happen is between the controller that creates the VPN and the ingress objects. And of course that fulfills our requirement for rapid creation, deletion, and modification of VPNs, because it's just a case of handing SID lists to ingress PEs. So again, what I showed before, we have an existing VPN, which we're going to call ADE. I want to create a new VPN, CDB, and I do this simply by going to each of those nodes, C, D, and B, and providing it with the SID list needed to construct each of the paths. Now, one of the things that came out of the N-word discussion was the need for these.
So I actually don't use that term, please. It's way too confusing for people given other meanings of that term, right?
All right.
So yes. So I'll just clear up. The reference was to network slicing,
Which I promised I wouldn't mention.
Right, however, I just want to clear up. So let's not use that term. And if you, yes, the subject about which there was a BOF or whatever. So
Yes.
thanks.
Yes, it was network slicing that I was talking about. The important thing here is that has a requirement for rapid and sort of potentially unlimited lower bounds for creating and modifying paths in the network. And this is about the fastest way you can do it. You just hand to an ingress node a new path. But it also has the characteristic that you may wish to manage the internal structure of that network in the network itself. So you hand the path list, and it discovers what each component discovers what is there. So, for example, running an IGP over the top. What we've done here is we've used SIDs to represent each of to color each of the different resource groups in the network, the fractions of a node or fractions of a link, and by reference to sits in the same color group, we can create 3 different virtual networks, as we've shown here, blue, yellow, and green. And so from the underlay point of view, we see all of the different resources. We see all of the different potential colors of the resources, and we color them late, so that initially everything is neutral and only given a color when it's needed to construct a network of a particular color. And then we partition things to create, in this case, the 3 different VPNs, and we specify the path through the 3 VPNs by SID lists. But the important thing is that we're only using at this stage SID lists to distinguish a VPN from the underlay, and we constrain the uses of a VPN, the users of a VPN, to the color that they are assigned. Again, we now produce an isolated system. This is using strict source routing paths, which is where I think we will end up when we are dealing with true isolation or loose source routing paths, because not all services require strict isolation. So there's a mixture of sort of hard and soft resource preservation that's needed, depending on the application, and maybe depending on how much bandwidth you've got in hand, so you can be a little less careful. Right, so the next thing we need to do is to integrate service function chains with this, because what we need to do is to include service functionality, service chaining functionality, both for virtual functions and for actually potentially the operation of the network itself inside the network. So, for example, if you were going to run OSPF on one of these VPNs inside the VPN, then you would have to have access to compute resources that were dedicated to that network, virtual network. So it's quite simple, really. You just specify, you have some function F that resides on node 3, identified by SID 103. Then by including 103 at node 3 in the instruction list, we add this to the service function to the path. There's a bunch of work going on, and there'll be a more comprehensive draft written for the next IETF that a group of us are working on. So what we've done is we've integrated service function chaining and segment routing in a seamless way in order to provide the dedicated resources and now service functions, but we need to go a bit further. So when you want isolation, you need to be stricter in terms of what you steer the packets through. And it's obvious that we can extend these mechanisms to steer a packet through any identifiable resource in the VPN. So, for example, physical and virtual interfaces, queues, specific NPUs, CPU cores, lookup engines, anything really. So the important thing is that by increasing the instruction set and by providing the right concatenation of instructions, we can steer the packets around the network to the right resources which may be reserved specifically for them. And we can also use this approach to tune the behavior of a resource. So, for example, an instruction might be something that influences the behavior, a specific behavior at a queue. For example, maybe you want to flush it. I think the important thing is that once we step into this world, then it's up to us to decide what instructions we might want to add and prepend to the front of a packet. But we're moving away from a simple network to more a set of network programmability. We're building more sort of an operating system in the network. So steering a packet through a resource. In VPNA, we might specifically go to Q103 for some packets and Q104 for other packets, and we might identify a resource as being a resource that's a component of a well-known object, router 102, or it might be a resource in its own right. It's up to us, once we cross this threshold, how we specify them. We think we need to support many different underlays, of which the two most important are MPLS and an IP. We need to be able to run over an IP underlay in two circumstances: one, to bridge between two MPLS domains, and the other case where we need to do it is where we wish to use a single control function or a control style to operate in both the IP and the MPLS world. And a number of you will have seen the two drafts here, draft U MPLS Unified Source Routing Instruction and draft Bryant MPLS Unified IPSR. Those two will be merged in sometime in the next 3 or 4 weeks, and we think they form quite a powerful sort of construct in this approach, because well, they allow us to build a very compact and unified approach to putting these instructions on the packet. So for those who haven't seen it, the IP encapsulation we would impose for this unification is to have the MPLS label stack that we would have otherwise created, put that in UDP, and put that in either an IPv4 or an IPv6 header. Note that we are supporting IPv4 and IPv6, which allows us to add some of this into a legacy environment. Also note that the interesting use of UDP is that it allows ECMP to work nicely in existing hardware, and it also is middlebox friendly. So tunneling over an MPLS, tunneling MPLS segment routing over IP works exactly as you would expect it to do. If in this particular case routers B, F, and D are not MPLS SR capable, then we tunnel across them in IP by simply doing an IP encapsulation, and the instruction at for example, E is to hop over, encapsulating IP and hop over to G. This is a very similar diagram, and it's deliberately a very similar diagram because the problem of hopping over and bridging across IP gaps in an MPLS network turns out to be almost exactly the same problem as building or using this technology in an IP network in order to introduce segment routing. So there's an elegance in that we should consider. And note that although I'm only showing connectivity here, at any particular point in the stack, I could show calling up a service function or routing through a specific queue or invoking any other feature. So what I've got here is a single compact data plane format that can support interconnection between MPLS segment routing islands, can support service routing, service function chaining, and can support segment routing over either IP version. Pretty well all of the data plane requirements already exist because RFC 7510 MPLS over UDP is the fundamental component in the IP case, and of course segment routing MPLS already exists. It's important, of course, to focus on the fact that these labels are merely 20-bit instructions, and not the packaging, and that the packaging in RFC 3032 format is merely a convenience. It's also important to remember that we don't need any of the MPLS control planes turned on to do any of this. So this is a unified approach that's got a lot of benefits. Initial focus on the control plane will be, so initial focus has been on the data plane, and we'll be going to the control plane next. We're clearly going to have to get it working under the classic IGPs. We're clearly going to have to support BGPLS and PCE controller. And the overlay can use either a dedicated control plane or a shared control plane, depending on what degree of sharing is permitted between the different VPNs. And that's a function of the isolation, both in terms of control stability as well as data interference. So what we kind of done really is to try and unify deterministic networking with service function chaining, with segment routing to build the new class of VPNs that some industries are asking us to put forward. So we can potentially have a virtual network with hard isolation, which is better than we get with classic VPN, where packets can bump into each other. We get the benefit of both hard isolation with statistical multiplexing. We get tighter integration between the underlay and the overlay so that we can draw on specific resources in the underlay. We can perform resource reservation on a per VPN basis. We're doing this with, we think, less state in the core compared to other techniques. And we've got an integration of VPN service functions and guaranteed performance. I think that's the end. So questions?
Okay, actually, I want to jump in here for a moment. So since the topic of network slicing was discussed, and so this has some relevance to network slicing. There was a BOF on Monday, and I want to make it clear that the process of the BOF is took place Monday. We're not going to have arguments about relevance and so on to this technology, or relevance of this to network slicing, et cetera. That's being done elsewhere. This is just informative and relevance.
Indeed, and I think it has, as I suggested, I think it has a scope that transcends that sort of mobility sort of application. Because I think this is of more universal applicability in the construction of networks.
Okay, just so I want to make sure we don't get into sort of, overflow from BOF stuff. So,
hi, this is Uma. I have 2 comments and 1 question. Actually, this is the closest work for net slicing I ever saw. Actually, I worked in net slicing solutions, 2 companies, and this is the closest work in the transport network domain. Thanks for this work. And the question is, in the stateful virtual networks slide, you said that to create a VPN, a set of SID list is created and provided each ingress at the VPN together with the packet selection criteria. I looked at the document. I couldn't find what is the packet selection criteria. If you can expand it, it's wonderful.
So we wrote the document sort of in haste, I suppose. We will be significantly expanding it. How you select the how you actually select the packets is kind of part of the dialogue between the owner of this network and the tenant. And we can use any of the ACL type techniques, or we can use an open flow selector or whatever, or we can just take everything from a port.
I can take this offline, but the specific requirement in one domain is you have getting GTP packets with QCA embedded in that.
Yes.
It's not per subscriber. It's all subscriber mixed up. You have 10 QCIs with different parameters there, and these traffic need to be mapped to these tunnels.
Right.
There is a gap there.
So can we in
VPN
fact take that one offline, because
okay. I'll take offline, but I want this to be expanded, this focus, like, for L2 VPN, L3 VPN, how do you do that?
Absolutely, absolutely.
Yeah.
But that will be part of the detail as we get further down.
Uma, there's a number of extensions to PSEP, to BGPLS to provide this granularity of filtering down. So tunnel to effect.
And there's the hardware.
No, I'm asking about.
I mean, that I regard as sort of cooking technology.
No, I'm asking about tunnel to fact mapping at the router, not at the.
Sure. Right. The router, I regard that as kind of cooking technology. We will figure it out when we get to that point of detail.
Adrian Farrell. 2 points. The first was I was one of the co-chairs of the net slicing BOF, and I don't want to prejudge what the IESG will do, but I think a strong theme that came out of that was don't wait on an overarching architecture to do work that is useful for operating building networks. You know, if there's work out there that needs to be done, whatever the purpose of that work, if it has value, then don't sit. So yeah, this is good.
So it's kind of result of some discussions on the BOF. We need to provide a way to friendly consume resource transport network. That's all we need to do for them. So let's stop there.
So is that a statement or an opinion?
Both.
My second point is more about this presentation, and I think I want to pick at your representation of VPN Plus as the customer having some control over the operation of the network.
No, they don't.
Right.
The customer
So-
demands certain characteristics of the network, and the underlay provides those with the resources and provides them with the way of identifying those resources.
That's great. So it turns out you want to pick at your representation of VPN Plus as well. So what came over in your slides was that the user, the person who had the VPN, was being given a tight coupling with the way the network was operated and built. And I think that tight coupling is between the controller and the network, not the customer and the network.
Yeah, so those, of course.
So actually, so we got 4 minutes left for this part of the discussion because MPLS is going to be starting at 10:40. So I'm going to cut the line and keep going, but just want to make sure that, yes.
Yeah. So I think we might have radical agreement then that this is really what you're talking about is a controller-based system where the controller has knowledge of what's needed and is operating the network using a variety of tools that we already have to achieve that. And I'm not opposed to overarching cookbook framework documents. I've written too many of them myself, but I don't think you're doing more than telling us that there are a lot of tools out there and we can put them together to run.
Absolutely. You and I have talked about many aspects of this. I was just surprised at how well the pieces fitted together to do something slightly bigger than we'd originally spoken of. I would say something else, and that's that.
So actually, why don't we move on to Lou's question, because we have 2 questions to get through in 3 minutes.
Lou Berger, 2 things. Your statement of you were surprised how everything fits together. I think a bunch of us are happy to hear that, and sort of makes sense to us because you're leveraging a whole lot of things. Well, we assume you're leveraging a whole lot of pieces that were already working here.
Indeed.
But it's not clear from your presentation or from your documents, which you are. And the one document that goes into some of the details misses a whole lot of work. You know, we have a way of doing TE topology, abstraction and control. We have ways of doing, we have models and frameworks for SDN control of transport or TE networks. Please bring them in. And then when we have that cookbook, it'll show how the whole pieces fit together. So that would be really nice.
Indeed. I don't want to invent anything I don't have to invent. I would like to call on existing protocols wherever we can, including the other subject close to your heart, which is DetNet, because I think there's a big overlap between this and DetNet. And
I agree, but I wasn't going to bring that up. My second point was actually, I do think you've highlighted a definition that we should be more focused on in the area. I'm not saying in which group, which is we don't have a good definition of SRTE, and we should.
Right.
So I think that is an implication of what you're talking about.
Wim Hendricks, Nokia. I agree, it's a good document to actually put the pieces together, which we all have, right? But I believe that in spring when we started, there was a bunch of use case documents written, which at the end of the day didn't go forward because we thought this was not really relevant for IETF. I do agree that segment routing over IP is something which is not fully fleshed out and needs further work, which is ongoing, I think. But the The question which I have is, what is the scope of this document? Is it just a framework which you put together? Because it's actually putting together the pieces which we actually have available in many working groups, and it's actually putting it together, but I don't see what's new to be done, or what's new, let's say, specifications which need to be done, or protocol work which need to be done from here in order to address these use cases.
Well, there are one or two documents that we need to complete, like the unified SR document,
Yes.
and we need to complete there's going to be a better version of the service function chain document. He's an
Okay,
author.
huh?
Correct, yeah, but that's for me, I agree with that.
Okay, I'm going to cut the discussion off here because we've used the allocated time for this. Yari, next presentation, please.
Okay, so I'm here to talk about draft that Jeff and I wrote about low latency applications. And sort of the background for this is that we saw a lot of references to work on latency sensitive applications, critical communications, low latency, and we're wondering what is this and what does it actually imply? And people were claiming this is a major change. Is it so? We're trying to understand what's going on and how it impacts internet. And is there new work for the IETF, the architecture levels? And there's kind of a big picture view into this. And this is work in progress. I'm here for a couple of different reasons, including the request for you guys to contribute. So we've seen many requirements for latency sensitive communications up here. Tactile internet requires 1 millisecond reaction time statement from somebody. Self-driving cars, another hard requirement. 5G has a ton of discussion about low latency or support for low latency applications and specific requirements. Again, the 1 millisecond number appears there somewhere in their requirements, and 10 milliseconds for more general latency figure. So these are kind of you can sort of think about this and they make sense in at least in some aspects that you for some of these applications you actually do need fast communications. There's also plenty of wild claims in this space. So all the way from let's go use all our old telecom tools and apply them, or let's redesign the internet because obviously we need to do that now because IP doesn't go fast enough. With the new IP, we can have different speed of light or something. And then there's various kinds of business changes sort of ongoing. One of them is actually that as you sort of move, or if you have low latency applications or demand for them, then you might need some of the resources need to be closer, so that might change the landscape a little bit in the cloud space, as an example. So I would not expect at least major changes in how the dynamics and economics of the internet operate, but it is true that the world does care about low latency. Some examples about things that are going on at the IETF and elsewhere, or the deployment, data centers being distributed around the globe, including cooperation with operators, advanced optimization techniques to get to those data centers with some DNS tricks. The industry is working on HTTP2 quick TLS 1.3 with 0 round trip time design, L4S, DetNet, 802.1 TSN, 5G radios, tons of work. We also have SDN and SFC techniques to make it possible to tailor better various kinds of routing paths through the network, make sure that you're sort of optimized for a given situation in your network. And at the application level, we have tons of tools also to help some of these latency issues. And so just to sort of recap where we are, it seems that we're working on the link layers, so the links are being improved, our routing mechanisms are being improved, our transport protocols are being improved, the security tools are being improved in terms of latency. Latency in applications is being looked at, network deployments are changing to take into account latency. And this is really just regular business at IETF and elsewhere. So One statement that could be made here, of course, is that it's all done, and there's nothing more to be done. To some extent that's true. There's plenty of work, and it's not a revolution in the same sense as some people might be expecting. But there is some first of all ongoing work, and then there might be some issues that we need to address. But it also might imply that there's some pressure for changing internet in bigger ways. It might cause some strain for the architecture in several places. So our draft tries to look at that, like what possible things we might be thinking in terms of a bigger change. Two slides about that here. So the first point to make is really that I see a lot of people working on particular details of networking and really focused on let's optimize latency on this link or this part of the routing fabric. But if you try to think about the possible applications of this, you have a factory with robots communicating with each other, or some kind of traffic control system where you really need to communicate quickly and make sure that your communications get through. You need to think about the system, the whole, like, where are the participants that need to communicate? How do we get to them? And often it's not just one link away, it could be further away. And then the other aspects than communication also included. So that's really, really important that we seem to be forgetting at times. There's obviously a trend of service placement in the network. It's no longer in if you have a web-based service somewhere, it's no longer in one server in your data center, but it's actually typically distributed around the globe in some fashion. So we're seeing that distribution happen. Might be going even more regional than it is today. We're seeing more cooperative solutions where the operators or the ISPs are working with content providers that, hey, let's have this box here, and make sure that everything goes as fast as possible. Edge computing is sort of coming and might be boosted by these requirements. There's going to be impacts on architectures that employ tunneling. So obviously, if you have a very low latency application and as part of the routing, you tunnel your packets 1,000 kilometers away, that's 3 milliseconds at least. So that might not work in all situations, and then there's multiple ways of fixing that. One is to move away from some of these tunneling approaches. The other one is to think about where you actually place the endpoints. Fortunately, some of that is actually relatively easy, or becoming easier today because of the cloud and virtualization techniques allow you to place functionality in different places in the network in much easier fashion than was true before. Also, there's going to be demands for cross-layer optimization. Look, if we put all these layers together, then we can cut half a round trip from this exchange, and then everything will be faster. Great. Well, that might be true. But there might be also costs, like your design will be more fixed. Your design will be more ossified. You can't change it as easily in the future, perhaps. So that is a consideration to think about, even at the IETF when we do our stuff. Yes, almost done. There's also design issues around. Do you have applications that talk to nearby nodes directly, or you go through the network, and that that tension seems to play out like in the car industry a little bit. So that's something to watch for. There's also folks who think about only the sort of the primary function of an application and might not be able to think about exceptional situations, exceptional, but most devices, for instance, need to have access to software updates now and then. And so typically in most things, you just don't communicate here, but you also need to communicate over there or far away. And so making sure that you include that, it's important. And there's tension between application kind of treatment of things and the routing layer treatment of things. And of course, a deployment story for any of these new ideas on QoS kind of mechanisms it's something to think about. I mean, we have lots of experience of not being able to deploy QoS because it's just difficult both technically, but also business-wise. Casey Claffey and Dave Clark had a very nice paper pointed to by our draft. You should go and read if you contemplate in designing any of these things. So that's the short intro to what we're doing in the draft. Thank you for the opportunity to talk about this. We're looking forward to questions and contributions. You know, what's happening in this space and so forth. We'd be happy to include more of this in the document.
Ning Zhong from Huawei. Yeah, I actually like this idea of view this low latency issue in the architecture view. So because I think that low latency, well, it's a hot topic, but it's quite difficult to achieve, to satisfy by using the single technology in IETF or internet technologies. Difficult to achieve different use case requirements. So I think that may build an architecture view that may be a cookbook to combine and have the gap analysis of existing technology to see if this reusing existing low latency tools in IETF can meet the requirements in the maximum sense. I think this is a good idea, and maybe some potential gap also should be analyzed between the different industry requirements. For example, to add, I think Broadband Forum also launched the project. It's called Broadband Assured IP Service. They have some requirement for the user service. So yeah, I think this is a good way to go, and we have a similar idea. So maybe you can talk about this later.
So and so you can respond, but and one more question from Lou. We don't have a lot of buffer time because MPLS is starting right after this, so we need to stick on schedule.
Yeah, just a quick response that, thank you. And, this discussion is also partially similar to what we just discussed about net slicing, that we're sort of trying to have this overall view, the big picture view, but that shouldn't stop, people identifying necessary things and going and doing them.
Thanks so much for this work. One of the things that we've identified in the existing QoS work, like what's going on in DetNet and Tees, is that from an architectural standpoint, we have a gap in how we get information from the application through the transport protocol down to the QoS-aware network on what the needs are of the application. And then how do we provide information back up through the transport protocol? And we see there's an opportunity for transport protocols to be QoS aware, both down and up. And but we don't see anyone looking at that. And that's certainly beyond the scope of the current work. So looking at it from the architecture side, maybe you can attack that and help us give us solutions in that area.
That's certainly an issue.
Thanks.
Thank you.
Thank you.
So we'll move on to the next agenda item. Jen Linkova will be talking about a proposed research group on path-aware networking.
Hi. So if you actually were in the path-aware network meeting on Wednesday, you can go back to your emails. For those who went to Ideas Both or got some other conflicts, I'm here to give you a short summary and explain what's going on and why it's going on. It's not my slide, so I hope I at least know all acronyms on it. So path-aware, what is this? So traditionally, we used to have a host which had one interface to the network, one IP legacy address, one interface, and there were routers which had a lot of interfaces. And it was probably one of the main difference, right? The routers are multi-homed, can forward packet between interfaces, and all host has to do is to send packet to those routers to be delivered. Now everything has changed. Now we can actually sometimes tell a difference between host and a router. I've seen discussion on the other mailing list, like, is my phone actually host or a router? It depends, right? Because if I enabling tethering on my phone, it suddenly became a kind of a router. So hosts now multi-homed as well. They might be multi-homed in terms of still having one interface which connects to multi-homed network, or just have more than one physical interface. So when host connects to a network, what does it know about the network? Traditionally nothing. It's a kind of black box, right? I'm sending packets and it magically appears on the other side or not. So sometimes we've just actually heard that it would be really nice, right, if host might get some information about the network and not treat it as a black box. However, there are two approaches. Routers are smart, right? All host needs to do is to give routers all those packets, and routers with all these beautiful routing protocols this group is talking about could deliver their packets in the best possible way, because routers run all those dynamic protocols, know information about path and so on. But people who sit in other rooms and mostly working with host might have different opinions. Host might know better how to send the packets and how to deal with retransmissions, packet lost, and host might have some preferences on how packets should be sent. And all routers need to do is to shut up, take my packet and deliver it. So let's back to the topic because I didn't have much time. So what is the path awareness? We can look at it as two problems. First of all, it's a control plane. It would be really nice to know we have different paths in the network, right? Because again, if my laptop is connected to my enterprise network, it's actually multi-home because it has different addresses from two different ISPs, and there are more than one internet path available for that host. But host might not even understand it. Then, when we know there are more than one path, what kind of path host could use? Are they all equal, or some paths might be more equal than others? There might be some characteristic of the network path which host or transport layer and application layer on host might need to be aware of. And then when we got all this information from the control plane, host needs to be able to use all that information and send packet as host would like through particular path. Why do we need a research group? Because it looks like there are a lot of people at IETF in different groups which working on that problem from different aspects, right? It might be, I apologize if you do not see your favorite work or your favorite working group here, because otherwise people will be complaining in the IETF mailing list that font is too small and they could not read the slide. So transport protocol, MPTCP, Rtgwg, aggregation approach, like I'm pretty sure some of you have been to Banana Boff. They're control plane indeed, like Spring. And my favorite topic is multi-home hosts, MIF work, which now you might have heard this week about PVDs and so on, right? So it would be really nice to get all of you in the room and start looking at this as a long-term research topic. So we could come back to IETF and talk about what needs to be done. So it's not the first time, right, we're trying to solve this problem. Long time ago, it was IPv4 source routing, when host actually was able to tell network how this packet should be routed, and then everyone agreed it's a bad idea. Security, scalability, and so on. Yes, and it was some work on integrated services, and I'm going to skip this. Yeah, differentiated services kind of works in MPLS networks at least. And then we decided to look at IPv6 as 128 bits IPv4 and reinvent source routing for IPv6. And again, people agreed it's a bad idea for more or less the same reason as it was a bad idea for before. However, V6 gives us more opportunities, right? Because I've been here a year ago in Berlin presenting enterprise multi-homing in IPv6 from routing and actually path awareness perspective, because multi-homed enterprise hosts need to get some information about available network path. So multi-homed host, I'm going to spend some time on it because I love the topic. So host might be connected via one or more physical, yes, I'll pay for it, physical interface and to the network. people try to solve this problem for a while, right? SHIM, I think there is an RFC on SHIM, but I do not think anyone's seen it deployed from mobile or multi-home host. And still, it was more for mobility. I mean, host could move between different networks, but it could not control which network to use. Oh yes, there is a lovely thing called Lisp, which kind of trying to solve the same problem, but again, more from a mobility perspective. Hosts do not have much control in this case. Yeah, multipath TCP, it's actually closer, right? Because host might influence where the traffic is going. Oh, segment routing. Yeah, I'm in the routing working group. So host, actually we sometimes can talk about tunnel endpoints as a host as well, right? Could send a packet through predefined route by using either IPv6 or MPLS, actually segment routing as well. And when we start talking about all this path awareness and giving host some information, the question is how host could get that information, preferably as dynamically as possible. So IPv6 segment routing, for example, how host could know what kind of headers to put into packet. One of the ideas proposed is to use DNS, because DNS is cool, almost as cool as BGP. We can use DNS for distributing almost any information. So yeah, host could ask, how can I, in the DNS, please give me path to the destination and get not just name, but some kind of path information as well. There are some papers published on this topic. I love this. I love provisioning domains, right? It's beautiful, right? So actually, yeah, host connects to the network. And if it's actually more than one network on a link, or it's more than one link, each network should announce itself. Okay, I'm here. Here is my network information. And there is an architecture RFC published a while ago. And again, question how host could discover it. And in our shiny new world of IPv6, we already have an information of configuring host, providing keys with any related network information, which called router advertisement. You could, a host might not just get a prefix and default router and DNS information, but also some other hints about what is available. And I think this draft been adopted in Interior, but I'm not sure because I missed the session. So it's all good. However, there are some politicals, or you might even sometimes say security problems, because operator might believe that I'm running the network, hosts should not tell me what to do, my network, my rules. However, end users might say, no, I'm paying for the service, I want to influence the path. And they might actually have totally conflicting interests, right? As an operator of enterprise network, I might want to use the cheapest uplink possible, while my host might prefer using the fastest uplink, and so on, right? So it's also a problem which need to be solved, among others. And we believe that the road to the destination might not be really easy, but it might be interesting and beautiful because there are so many interesting problems to solve. So it's a proposed research group. We are going to meet in Singapore. So please come to the room because I'm so sorry, it was a scheduling conflict with ideas and some other sessions. So unfortunately, we really missed routing people in the room on Wednesday. Please come to Singapore. If you have any ideas what to discuss, what should be presented, please contact chairs anytime. Thank you.
Thank you, Jen. And to add, the recording of the session is available on YouTube, so you could go and watch it. It's rather interesting. Not only this one, but the original Panergy session.
So if there are no comments on that, we're going to close the session. Before people get up, however, let's make this a very quick transition because we've eaten 3 minutes into MPLS's time already. So if you're staying in for MPLS, please stay. If you're leaving, please leave. Any side conversations, have them outside, and let's do a quick transition to MPLS.
Thank you, everybody, and we'll see you in Singapore.
You were very efficient.
That was their local.
You need those?
Yep.
And you need yours.
You have one more.